refer to the sheet titled Permutation Combinations An Initial Stint. An initial stint, some very basic problems on counting principles that we collected in the last class, and let's breed familiarity with those basic ideas by means of these problems. So the first problem of this sheet is about 5 flags of different colors. 5 flags of different colors. This problem involves 5 flags, say F1, F2, F3, F4, F5. These are 5 flags of different colors that are available to you. And you want to create a signal using one or more of these flags. You want to create a signal using one or more of these flags. How many signals could be created? Given that you can use any combination of F1, F2, F3, F4, F5, you can use 1 flag or 2 flags or 3 flags or 4 flags or all 5 flags to create a signal. Right? Please come in. Right? So you could create signals using any combination of flags. But there is 1 unit of F1, 1 unit of F2, 1 unit of F3. That's for sure. But a signal could be created by using any one of these flags, right? So there would be, let's say, a bunch of signals. There would be a bunch of signals that could be created from 1 flag, right? 1 flag. How many signals using 1 flag? 5. 5 signals, right? 2 flags. Hmm? 5 into 4. That is 5p2 essentially. That's right. 5 into 4. This will turn out to be 5 into 4. That means 3 spaces. 3 spaces to be filled up, rather 2 spaces to be filled up using these 5 things. So the first space can be filled up in 5 ways, the second space could be filled up in 4 ways. That makes it 20, which is also the same as 5p2. 3 flags, 5p3, or the problem reduces to filling up 3 spaces. So that would be 5 into 4 into 3. That is 60, which would be the same as 5p3. 4 flags would be 5p4. And 5 flags would be 5p5 or 5 factorial. 5p5 or 5 factorial. So all that you need to do is 5 plus 5p2 plus 5p3 plus 5p4 plus 5p, which is 5 factorial. If you add all of them, what does it turn out to be? 325. So the total number of signals that could be generated are 325. Right? Make sense? I'm assuming you would have got it right independently as well. Right? Okay. The second problem is about 10 students. We seek to organize 10 students in a row. We seek to organize 10 students in a row. So the order will matter. The order will matter. However, the condition is that A should be ahead of B, who in turn is ahead of C. That means in any order in which I arrange these 10 students, who should come first? A should be ahead of B. A should come first. And then somewhere down, B should come, and then somewhere down, C should come. This is how the 10 students have to be arranged. In any arrangement that we are seeking to create, A should come before B, and B should come before C. Right? Question is, how many such arrangements could be created? First of all, if I didn't have a condition, unconditionally, unrestricted manner, if I have to arrange 10 students, in how many ways can I arrange 10 students in a row if there was no restriction? 10 factorial ways, right? Now, look, these ABCs, in as far as the order is concerned, various orders of ABC could appear. In any arrangement, the various orders in this 10 factorial, ABC could come in this order, or it could be BAC, or it could be CAB, and so on and so forth. Various orders are possible. In which, so how many such orders of ABC are possible? 3 factorial? 3 factorial orders of ABC, which is 6, out of which 1 is relevant. 1 is relevant. That means of all the arrangements, 1/6 is the required arrangements, isn't it? This arrangement will constitute 1/6 the total, right? Because there are 6 such arrangements. So this will constitute 1/6. That means of 10 factorial, 1/6 of 10 factorial will give you the required number of arrangements. Yes or no? 1/6. So the required number of arrangements is going to be 1/6 of 10 factorial. 1/3 factorial, that is. Yes or no? Right? So far so good, right? Clear? Number 3. Again, there are 10 students and we want to arrange them orderly in a row. But what we want is that A always lies between B and C. A always lies between B and C. That means what is acceptable in any arrangement is that B should come ahead of A and then C, or CAB. Yes or no? Now the total number of ways in which ABC could be permuted amongst each other is 3 factorial. Yes or no? That means 6. That means only 2 out of 6 is relevant. That means 1/3 is relevant. Yes or no? Only 1/3 of the count is relevant. So the required count, total number of ways in which 10 students could be arranged is 10 factorial, of which 2 out of 6, that is 1/3, is relevant. So the required count would be 10 factorial by 3 is the number of ways in which A would lie between B and C. It could be this or this. And all possible ways in which ABC could be permuted is 3 factorial, which is 6, of which 2 is relevant. 2 out of 6 means 1/3. 1/3 of the total permutations would be the required number. Yes or no? Right now? Number 4. Again, we are talking of 10 students. We are talking of 10 students to be arranged in a row such that A and B are always between C and D. That means flanked by C and D, you could have AB like this. Flanked between C and D, you could have BA like this. Or flanked between D and C, you could have AB like this. Or flanked between D and C, you could have AB like this. Yes or no? Right? So how many are relevant? 4 are relevant. And what are the total number of ways in which I could permute these? 4 factorial. 4 factorial are the total number of such permutations, of which how many are relevant? 4. So what fraction is relevant? The 4/4 factorial is the relevant fraction of what? Of the total number of permutations of 10 students, which is this. So 10 factorial divided by 6. 10 factorial divided by 6. Yes or no? Just get a hang of, these basic counting principles. I'll use these prompts as the mouthpiece to communicate those very fundamental ideas. Okay, number 5. What is the total number of permutations of 10 different things taken not more than 4 at a time? It is given that each thing may be repeated any number of times. That means there are multiple copies of each thing available, right? So I have thing T1 and there are multiple copies of T1 available. Then there is thing T2, an infinite number of copies of T2 available. T10, an infinite number of copies of T10 available, right? Now, we want to create permutations, making sure that not more than 4 things are selected at a time. Similar or dissimilar, that does not matter, right? So, if I select one thing at a time, 10 ways. One thing would give me 10 ways, right? If I select 2 things, 10 into 10. 2 things, selecting 2 things is like filling up these 2 spaces with multiple instances of T1 to T10 available. So this space can be filled up in 10 ways, any one of these. And then, no matter what I have used to fill the space up, I could replicate the same thing here because there are multiple instances of the same thing at our disposal. So there are 10 ways of filling up this space. So that makes it 100. Yes or no? 2 things selected. 3 things selected, 10 cubed. 10 into 10 into 10, 10 cube. And lastly, 4 things, filling up 4 spaces, right, 10 to power 4. Ten ways of filling up this, 10 ways of filling up this, 10 ways of filling up this, that makes it 10 to power 4. And the total count would be 10 plus 100 plus 1000 plus 10,000. That will be the total count. You need to add all of them. 10 plus 100 plus 1000 plus 10,000. Right? So that makes it what? 11,110. 11,110 is the total count. Number 6 is about 100 students. With roll numbers 1 to 100. 100 students with roll numbers 1 to 100. So let's say S1 is the student with roll number 1, S2, S3, S99, S100. These are the various students with roll numbers 1 to 100. Okay. Now, what is it that we want to do? We want to select 10 of these students. We want to be able to select 10 of these students and list them out according to their roll numbers in increasing order. List them out according to their roll numbers in increasing order. Now, in how many of these arrangements will rank 50 appear at the 6th position? See, there are 10 positions. These are the 10 positions. Same. 1, 2, 3, 4, 5, 6, 7, 8, 9. These are the 10 positions. What we want to do is, we want to make sure that rank 50 appears at the 6th position. That means I want S50 to appear at the 6th position. This is roll number 50 appearing at the 6th position. Right? So this is fixed. S50 is fixed here. Now, I want to play around with the rest. Obviously, these are students. There aren't multiple copies of them available, right? So there is no question of repetition. And you know, all that you have to judge by common sense. No one will tell you repetition not allowed in this. Where will you get clones of each one of them, right? Okay. Now, first thing first. If this is S50, then these spaces have to be filled up from the first 49 roll numbers, because realize that everything that comes before this must be less than 50, right? Because they are arranged in ascending order. So that means S1 to S49 will populate these positions. S1 to S49 will populate these positions. That means how many available to populate these positions? 49. Okay. So, and how many spaces are required to fill up? 5. So, 49 C5. I select 5 from 49 available. Now, once I have selected 5, I want to arrange them in ascending order. In how many ways can I arrange them in ascending? Only one. There is only one way. If there are 5 numbers given, then there is only one way in which I can arrange them in ascending order. Yes or no? Is it not? Right? So these spaces can be filled up in 49 C5 ways given this fixed. Now, these have to be filled up from numbers S51 to S100. That means 50 numbers. There are 50 available designations for this, right? From 50, I need to select 4. Yes or no? These are 4 spaces. And they have to be selected from S51 to S100. S51 to S100 is 50 roll numbers available. Select 4. Once I have selected 4, in how many ways can I arrange them in ascending order? Only one. So fixing this 49 C5, and then these would be 50 C4. So the required count would be this and this. That means 49 C5 into 50 C4 is the required count. 49 C5 into 50 C4 is the required count. Yes or no? Can I wipe this off? All very simple, isn't it? 16 people participate in a picnic. Number 7. 16 people participating in a picnic. And 6 different works have to be allocated to different people. That means 6 people have to be selected for different works, right? Say, these are the things that have to be taken care of: W1, W2, W6. These are the various things to be taken care of. And therefore, 6 people are required to take care of W1, W2, W3, W6, right? Now, however, subject to a condition. In this group of 16 people, there is Mr. and Mrs. A, male, female. There is Mr. and Mrs. B. And there is Mr. and Mrs. C. Okay. Now, in my choice of these 6 people, I have to make sure that exactly one is selected from here, exactly one is selected from here, exactly one is selected from here, right? So 3 people would be selected from these. Now, remaining how many? 10 people. These are 16 people. These are 6 people, 16 and all. Remaining how many? 10 people. From the remaining 10 people, I want to select how many? 3 people, right? So once I've selected 6 people, once I've selected people, then I can arrange them in these spaces, because the same 6 people could be assigned different activities in this W1 to W6. So there are 2 ways of selecting from this slot, either Mr. A or Mrs. A. 2 ways from B, 2 ways from C. Yes or no? And then there are 10 people remaining. These are 6 of them, from which I need to select 3. So that is 10C3. Now, these are the number of ways in which I could have selected 6 people. But these 6 people could be arranged in 6 factorial ways here. So into 6 factorial, into 6 factorial. That's the required count. That's the required count. Yes or no? Right? See, this is the number of ways in which I could have selected 6 people, right? But those 6 people have to be assigned these 6 activities. That means those 6 people have to be arranged in these 6 slots. In how many ways can I arrange 6 people in 6 slots? 6 factorial ways, isn't it? Right, Ayush? Now, whatever this turns out to be. Very simple, isn't it? Very simple. How many distinct lines can be drawn through 8 points? 8 points. No 3 collinear. How many lines can I draw? 8C2. I need to just select two points to create a line. So it's about the number of lines that could be drawn is about selecting 2 points out of 8 available. That would be the ways in which lines, if there are no 3 points that are collinear. If there are no 3 points that are collinear, yes or no? Which turns out to be 8 factorial by 6 factorial into 2, 56, 28. 28 ways. Yes or no? Right? That's 8. There are again 8 points, but this time they say out of 8 points, 4 are collinear. 4 are collinear. Exactly 4 are collinear. How many distinct lines could be drawn? Okay. So what I do is, first of all, if no 3 were collinear, then it would have been 8C2. Now in 8C2, what was the contribution made by these 4 points had they not been collinear? 4C2, the number of lines that they would have contributed in this 8C2 would be 4C2. So remove the contribution of these 4 collinear points, 4C2. That means, but of course, together they would constitute 1 line. So restore that count 1. Yes or no? Yes. I'll explain, don't worry. There are 8 points. If no 3 were collinear, the number of straight lines that would have been drawn would be about selecting 2 points out of 8. Every time you select 2 points out of 8, you construct a line. So you could have done that in 8C2 ways, which turns out to be 28. Provided no 3 were collinear. However, they say out of these 8 points, four are collinear. These are 4 other points and 4 are collinear. Now, if no 3 were collinear, the count would have been 8C2. But 4 are collinear, right? So now, if non-collinear, if no 3 of these were non-collinear, then the number of straight lines they would have contributed would have been 4C2. So remove the contribution made by these 4. Out of 8C2, remove the contribution made by these 4C2. Right? That means all the lines that could have been constructed out of 4C2 have been removed. But there is one line which you would have to add. One line that is created out of these 4 points, which is this. Yes or no? 4C2 is 6. So this is 29 minus 6, that is 23 ways. 23 ways. Yes or no? Clear? Simple, isn't it? Number 10. How many distinct lines can be drawn through 8 points, in which 4 lie on a straight line and 4 lie on another straight line? Right. 3, 4. These are 4 points lying on a straight line. And another straight line, there are 4 more points lying. There are 4 more points lying. Okay, how many lines could be constructed? Okay, so this was P1, P2, P3, P4, and this was P5, P6, P7, P8. These were the 8 points, right? Now to create a line, forget this line and this line. P1 could be matched with P5 to P8, 4 ways of dealing with P1, right? You could have created 4 lines from P1 using any one of the remaining 4 points as the second point, right? So 4 lines from P1. Similarly, 4 from P2, 4 from P3, 4 from P4. So that makes it 4 into 4, 16. Yes or no? Plus 17 and 1, 18. So plus 1 plus 1. That makes it 18. See, there is a line P1, P5, P1, P6, P1, P7, P1, P8, 4. And then there is a line P2, P5, P2, P6, P2, P7, P2, P8, another 4, 4, 4. That makes it 16, 17, 18. Yes or no? 18 straight lines could have been drawn. Now, 11 and 12, problem numbers 11 and 12 is about this set of numbers 1, 2, 3, n. Is about this set of numbers 1, 2, 3, n, right? In how many ways, and we want to select 3 numbers from this given set such that all 3 numbers are consecutive. I want to select 3 numbers such that they are all consecutive numbers. Now that's very simple. I could have selected like 1, 2, 3 one way, 2, 3, 4, 3, 4, 5, and the last number would have been n minus 2, n minus 1 and n. Yes or no? These are the only ways, isn't it? Isn't it? So that makes it 1, 2, 3 up to n minus 2, that is n minus 2 ways. Yes or no? N minus 2 ways, 3 numbers could have been selected such that they are consecutive. So n minus 2 ways, very simple, isn't it? N minus 2 ways to select 3 consecutive numbers. Okay. 12. In how many ways 3 numbers could be selected from this set such that not all 3 numbers are consecutive. 2 could be consecutive, but not all 3 are consecutive. Or no 3 are consecutive, but I shouldn't have all 3 consecutive. I shouldn't have all 3 consecutive. What is the total number of ways in which I could select 3 numbers? NC3. From this, I remove those cases in which 3 are consecutive. These are the total number of ways in which 3 could be selected. These are those in which 3 are consecutive. So this minus this will give me the total number of numbers in which no 3 are consecutive. Not all 3 are consecutive in any choice of 3. Yes or no? Clear, no? In a dance competition, the final round has 10 participants. The final round has 10 participants. It has 10 participants. And in each performance, 2 dancers will perform. In each performance, exactly 2 dancers will perform. Mr. Karthik has decided to see exactly 10 dance performances. Has decided to see exactly 10 dance performances. In how many ways can he select the dance performances? Okay. So first of all, every time I create a pair from 10, there is a dance performance that I am talking of. Question is, how many pairs can I create from 10? 10C2. Right? For a performance, 2 dancers are needed to be selected from 10. In how many ways 2 dancers could be selected from 10? 10C2. So these many performances, every choice of 2 dancers will lead to 1 performance. So these many performances, these are the number of performances. These are the number of performances. Which is how much? Let's see. 10 factorial by 8 factorial into 2 factorial. 10 into 9 by 2. 45. Yes or no? There are 45 performances in all, and Mr. Karthik wants to select only 10 of these. In how many ways can he select 10? 45C10. So he would select 10 performances in 45C10 ways. 45C10 ways. Right? Option A. Can I wipe this off? So there is a word, Deepmala. There is a word, Deepmala. And we want to use all the letters of the word and create various words out of that, right? But there is a condition. There is a condition. Two vowels are together. How many vowels are there? E, E, A, A, right? There are 4 vowels. Out of these 4 vowels, 2 must be clubbed together, the other 2 must be clubbed together. Not 2 similar vowels. It could be EE and AA constituting one group, or EA and EA. Both are possible, right? You know what I'm saying? So now, let's say case 1. When I have one group EE, the 2 E's and the 2 A's coming together. Okay. Look upon them as one single unit. Now, what are the total remaining numbers? 1, 2, 3, 4. Right? D, P, M, L. These are the 4 remaining letters. These are the 4 remaining letters. So what I do is, even before I allocate them their designated positions subject to the condition, I could have arranged DPML in 4 factorial ways. Yes or no? I could have arranged DPML in 4 factorial ways. Yes or no? So first of all, DPML, the total number of ways in which they could be mutually permuted is 4 factorial ways. Right? Now, the EE and AA would have to be placed here, or here, or here, or here, or here. How many ticks are these? 5 of these ticks. In which, how many entities have to be placed? 2 entities. This is one entity, this is another entity. Yes or no? So, 5C2 ways. I need to select 2 of these ticks, in which, in one of the ticks, this would be placed, in the other tick, this would be placed. That means from 5 ticks available, how many do I need to select? 2. In how many ways can I do that? 5C2 ways. Okay. Now, interchanging these E's and interchanging these A's will not make a difference. So this is the total count. Yes or no? This is the total count. Is it? No. So this is 240. No, in this itself, EE and AA, I've selected 2, but they could be interchanged in the sense that 2 have been selected. For example, you know, I could have placed EE here and AA here. This is only my choice of 2 spaces from 5 available, but the AA and EE are interchangeable. That means I will have to double the count, because yes or no? I will have to double the count. Yes or no? Because AA could have come here, EE could have come here, for example. This is only selecting a slot for EE, selecting a slot for one unit, selecting a slot for another unit, which is 5C2 ways. But then in these 2 slots that I have selected, in the first I could have placed EE and AA, or in the first I could have placed AA and then EE. So that will double the total count. Yes or no? So this is 10, 24 into 2, 48. That makes it 480 ways in the first case. 4 factorial 24 into 10 into 2. That makes it 480. That is case 1. Now case 2. My entities are EA and EA. So this unit and this unit. So first things first, I will permute DPML in 4 factorial ways? Yes or no? DPML to be permuted in 4 factorial ways? Now, I have to select 2, in which in one I'll place EA, in the other one I'll place the second EA. So 5C2 ways. 5C2 ways of selecting 2 slots. In one slot this will be placed, in the other slot this would be placed. But this EA could also have been AE, so the count gets doubled. Also, this EA could have been AE and EA, so the count one more time gets doubled one more time. Yes or no? So that makes it 960, because just double of this, so that makes it 960 ways. So 960 plus 480, 1440 is the total count. 480 plus 960, 1440 is the total count.